A circle has center G and points M and N lie on the circle. Line segments MH and NH are tangent to the circle at points M and N, respectively. If the radius of the circle is 168 millimeters and the perimeter of quadrilateral GMHN is 3,856 millimeters, what is the distance in millimeters between points G and H? Okay, so we have a circle with center G. Then we have points M and N, which are on the circle. And then we have some point H that is connected to N and M by a line segment. So this is NH and MH. And then we're told that the radius of this circle is 168. And that the quadrilateral that comprises of these two radiuses plus MH and NH has a perimeter P, let's just say P, of 3,856 millimeters. We need to find the distance between G and H. Okay, so the first thing we can do is find the length of these two sides, which is just the radius. So let's redraw this quadrilateral actually. It looks something like this. So both these sides are 168. And so we need to find the lengths of these two sides. Well, we know that these two sides are equal. And we know that the perimeter adds up to 3,856. So let's just say these two sides are both of length x. So the perimeter of this shape is 168 plus 168. So that's just 168 times 2. That's equal to 336 plus the lengths of these two sides. So that's just 2x. And that should equal 3,856. Okay. So, and we know that these two sides are equivalent because we're told that line segment MH and HN are both tangent to the circle. So that means they form a right angle here. And if they both converge to this point H, then in this quadrilateral, these two segments are equivalent. Okay, so back to this equation here. We can solve for the value of x. We can move this 336 to the other side. So we'll be left with 2x equals 3,856 minus 336. That's equal to 3,520. Then we can divide that by 2 to get the value of x. So we'll divide that by 2. And so x equals 1,760. So the length of these two sides here is 1,760. So x equals 1,760. So now we need to find the length of this distance. Well, going back to the problem, like we mentioned, the MH and NH line segments are tangent to the circle. This means that this line segment is perpendicular to the radius going from the intersection between the line segment and the circle to the center. So this right here is a right angle, which means this here and this here is a right angle. So if we split this quadrilateral in half here across this segment that goes from G to H, we have a right triangle up here. So we can find the length of this hypotenuse. We'll just call it Why? By using the Pythagorean theorem on this triangle. So here I'll redraw this triangle. So this is the right angle. These are the two sides, 168, and then this side that we just solved for, 1760, and this is the hypotenuse. So we can use the Pythagorean theorem. So a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. So let's plug in these values into the Pythagorean theorem. So we'll have 168 squared plus 1760 squared equals y squared. So we can add these two terms together. So 168 times 168, that's 28,224 plus 1760 squared. That's 97,600 equals y squared. So that means y is going to equal the square root of all this. So we can square root both sides to get rid of the exponent. So the square root, so first let's add these two quantities. So 3 million plus the 28,224 gives us this big number, and then we can just find the square root of that, which is 1,768. So the length of this distance from G to H, which is the hypotenuse of this triangle, which we denoted as y, is 1,768. So answer choice D.